Okay, salam sejahtera. Okay, so today we will continue with the last subtopic 1.4, charge in a uniform electric field. Okay, so in a uniform electric field, meaning that it is on the paraplate. Okay, so for 1.4, charge in a uniform electric field, actually we have 4 cases. So we go to the first cases. The first one is the stationary charge, meaning that initially the charge is not moving. Okay, so the charge here may be positive charge or maybe negative charge, depends on the questions. Okay, so consider a particle of a charge and the mass m is a stationary and placed in a uniform electric field. So usually uniform electric field will happen only in a parallel plate. Okay, the electric force exerted on the charge is given by F equals to EQ. Okay, F equals to EQ. Okay, so meaning that when we put a test charge into the electric field, it will experience a electrostatic force. Okay, since the particle is stationary, meaning that initially it's not moving, so the net force acting on the particle is 0. So the electric force on the particle is equal to the weight. Okay, so weight of the particle, if let's say your F net equals to 0, meaning that your F, meaning that the electrostatic F acting on the particle will equals to the weight that acting downward. Okay, so therefore our equation EQ will equals to mg, since just now, since F equals to weight. Okay, so we look at these two examples. Okay, so as I mentioned, it may be positive charge, it may be negative charge, depends on the questions. Okay, so if let's say this is a positive charge, of course this positive charge will attract upward to the negative plate. Okay, because positive will attract to the negative plate. And our weight is always acting downward. Okay, our weight is acting downward. So when we say F net equals to 0, meaning that our force, attractive force acting upward will equals to the weight acting downward. Okay, similar for negative charge. Similar for negative charge. Of course, for negative charge, it will attract to a plate, a positive plate. Okay, it will attract to the positive plate. Okay, so if let's say F acting upward and your weight will acting downward. Okay, so therefore our if this is a net force. Okay, so if this is a net force, F net equals to 0, okay, meaning that the force acting upward will equals to force acting downward. Okay, so force acting upward is our attractive force and force acting downward is our weight. Okay, so we can write it as EQ equals to mg. Okay, so this is case number 1. Okay, case number 1. Okay, where initially it's not moving, but when we on the power supply, your charge will attract to positive charge will attract to negative plate. Negative charge will attract to a positive plate. Okay, so this is the first one. Okay, next we go to the case number 2. Okay, case number 2 is a charge moving perpendicular to the field. Okay, for this case is actually a bit harder because it involves not only one dimension. Just now only one dimension, only y component. But for charge moving in perpendicular to the field, it involves 2 dimensions. Okay? Okay, consider an electron. Okay, it may be positive or it may be negative or positive. Okay, it depends. So for this case, if let's say there's a positive electron in a negative charge with the mass m, enter a uniform electric field E perpendicularly with the initial velocity. So there is an initial velocity. Okay, it is moving horizontally. Okay, the upward electric force will cause the electron to move along the parabolic path. Why it is parabolic path? So we refer to this diagram. Okay, we refer to this diagram. Okay, so initially, if when we off the power supply, meaning that there's no power supply, your negative charge actually it will move straight. Okay, it will move straight. Okay, it will move straight. Because there's no any forces that pull the charge. Okay, so I draw again. Okay, so if let's say initially when we there's no power supply, there's no electric field, so your charge will move straight. Okay, it will move straight. Okay, but when we on the power supply, when there is a potential difference between the two plates, when there is an electric field produced in between the two paraplate, meaning that this electron, okay, this electron not only will move to the right, but at the same time it will experience a electrostatic force. Okay, it will experience an electrostatic force. Okay, so at the end it will move in a parabolic path. Okay, meaning that this electron initially it will move in a initial velocity u. Okay, but when it enter to the paraplate, it will experience a electrostatic force, meaning that this negative charge it will pull to the positive plate. Okay, it will pull up to the positive plate, because this is a negative charge. Okay, because this is a negative charge, negative charge, so it will pull to the positive plate. So as a resultant, it will move in a parabolic path. So it will pull in this direction. Okay, so meaning that at any point in the paraplate, there is a velocity and there is a electrostatic force that pull. Okay, so this is the case number 2. Okay, case number 2 where your charge is moving perpendicular, okay, perpendicular to the field. Okay, because your field is in this direction. Okay, so this is your field. Okay, and your field is perpendicular with your velocity, so it's 90 degree. Okay, it's perpendicular. Okay, so we look at the equations. Okay, from the second law, F equals to ma. Okay, so the electric force, okay, the electric force is F equals to ma, and we can also write it as F equals to EQ or QE. Okay, so it depends. If this is a negative charge, we substitute negative charge. If this is a positive charge, we substitute positive charge. Okay, so this one only happen in our paraplate. So if let's say we combine F equals to ma and F equals to EQ, finally we have this equation. Okay, we will get the acceleration. Okay, the accelerations of the electron is A equals to E over M. Okay, some book they will write EQ. Okay, some book they may write like this. Okay, some book they will write EQ over M. Okay, so this Q actually it depends. It depends whether it is positive charge or it is a negative charge. Okay, so if this is a positive charge, meaning that it is we need to substitute positive 1.6 times 10 to the power of negative 19 coulomb. If this is an electron, okay, if this is an electron, so we substitute negative 1.6 times 10 to the power of negative 19 coulomb, negative, if this is a negative charge. Okay, can you understand? Okay, and M here, it also depends. Okay, it depends whether it's a mass for proton or it is a mass for electron. So it depends on the questions. Okay, it depends on the questions. Okay, if you don't know what is the value for the mass of the proton, if they say the question is not given, you can always press calculator. Okay, you press constant 0, 1. Okay, you press constant 0, 1, so it will come out the value for the mass of the proton. Okay, so if you try to calculate, you press the calculator constant 0, 1, you will find out that the value for the mass for the proton is 1.67 times 10 to the power of 27 kg. Okay, so this is the mass of the proton. Okay, you can press constant 0, 3. Okay, 0, 2 is a new neutron. So we press 0.3. So if you press again constant 0.3, you will get answer is 9.11 times 10 to the power of negative 31 kg. Okay. Okay, we also can press a constant 23. Okay. So constant 23 is the charge, value for charge. Okay. So we can press constant 23 to press the value for the charge. Okay, so what is the difference between the positive and negative? Only the symbol. Okay, for proton and electron, charge for proton is positive 1.6 times 10 to the power negative 19, but for electron it's negative 1.6. So you just put positive or negative, but the value is still the same. Okay, so the path made by the electron is similar to the motions of the ball projector horizontally above the graph. Okay, so meaning that actually this one we need to go back to chapter 2, semester 1. Okay, chapter 2, semester 1. Okay, where we can, okay, I will draw a table. Okay, I will draw a table. Okay, to show you. Okay. Okay, so if you refer to this diagram, we refer back. Okay, so if we refer back to this diagram, and we draw another we draw a table. Okay, you can refer to my summary. Okay, you can refer to my summary. So meaning that if let's say this one it involve two dimension. Okay, it involve two dimension. Okay, where it involve x component and also it involve y component. Okay, so the first one, okay, initial velocity. Okay, so initial velocity, we refer to this one. So initial velocity is initially we only have ux, but we don't have uy because it's not moving, it's moving horizontally. We refer to this part. Okay, you refer to this part. So initially we only have ux. Okay, but uy, of course, is equals to 0 because it's not moving to upward. Okay, and then velocity. Okay, the final velocity or the velocity, okay, we also have ux and also it will attract upward uy. Okay, so that's why our vx will always equals to ux because there's no forces acting on x component. However, for vy, you must use v equals to u plus a t to find. Okay, you must use the equations, the formula, the four equations from chapter 2. Okay, next is the acceleration. Okay, so for ax equals to 0. Why? Because there's no forces acting on x component, and vx will always equal to ux. Okay, so that's why acceleration for x component is equals to 0. Okay, but for y component, because there is a force acting, okay, the charge is accelerate. Okay, so we can write F equals to ma and mf also equals to eq. So our acceleration, we can write it as over eq over m. So this is a for y component. And remember, your ax will always equals to 0. Similar like our gravitational accelerations, last chapter, the free fall motion. Okay, and number 4 is the displacement. Okay, so x will also always equals to uxt because acceleration is equals to 0, and sy we can find by using ut plus half at squared. Okay, plus half at squared. Okay, so this is the equations that we can use for if let's say the electron or the charge is moving perpendicular to the field. Okay, so this one you must remember. Okay, and just now this one already put it in the table. Okay, so if let's say x component, your vx always equals to ux as it's always constant, but your vy you can use v equals to u plus at. Okay, displacement sx will always equals to uxt, but for y component, you must use the equation x equals to ut plus half at squared. Okay, where our A we can substitute, okay, we can substitute the value A is equals to EQ over M. This one also you can change to EQ over M. Okay. Okay, next one is the case number 3. Okay, this case is quite easy also. Actually, it's a parallel. The charge is moving parallel to the field. Okay, so meaning that the charge initially with the mass M is moving. It's moving parallel. Okay, just now number 2 is moving perpendicular. Now it is moving parallel. Okay, so since it's moving in the electric field, so the charge will experience a electric force. It will pull up. Okay, it will experience a attractive force. Negative will pull to the positive plate. Positive charge will pull to the negative plate. Okay, since only electric force exerted on the particle, thus the force contributes the net force. Okay, and cause the particle to accelerate. Okay, it will cause the force to accelerate. Okay, so therefore, F equals to ma and F also equals to EQ over M. So our acceleration is equals to EQ over M. Okay, acceleration is equals to EQ over M. Okay, so again, your Q, okay, your Q can be a positive, okay. If let's say positive charge, you put positive 1.6 times 10 to the power negative 19 coulomb. Okay, if let's say it's negative charge, you put negative 1.6 times 10 to the power negative 19. Okay, if this is a proton, okay, so you put positive. If this is an electron, so you put negative 1.6. Okay, and again, M, if you don't know the value, actually it will give in the constant list, but in case you don't know, you can press calculator, okay, where your MP, okay, MP is equals to, you press the calculator, constant 0, 1. Okay, constant 0, 1. So you will get our MP is equals to constant 0, 1. So you will get MP is 1.67 times 10 to the power of negative 27 kg. And also M electron is 3, not 3, 9 point. Okay, you press calculator, constant 0.3. Yeah? Okay, constant 0.3. So you will find out that the value for electron, the mass for the electron, okay, is 9.11 times 10 to the power of negative 31 kg. Okay? Okay, of course your E, okay, E, because this is our, still remember we have the equations, okay? Okay, we have two equations for E, okay? So for paraplate E, we must write E equals to our paraplate is equals to V delta V over D. So this is for parallel plate. Case for parallel plate. Okay, we also have another E. E equals to KQ over R squared. Okay, this one is for point charge. Okay, this one is for point charge. So for paraplate, we use this equation. Okay, we use this equation. Okay. Remember, E, we can, for paraplate, we must use delta V over D. Okay, delta V over D. Okay, next. Okay, because the electric field is uniform, because this is a paraplate, it's a paraplate, and constant in the magnitude and also directions, then the accelerations of the particle is also constant along the paraplate. Okay, okay, so if we refer to this positive charge, okay, positive charge. So case number 3 is the charge is moving. Okay, initially the charge is moving. Okay, initially the charge is moving. Okay, and if we initially before the power supply on, so when we on the power supply, what happened to this positive charge? It will attract to the negative plate. Okay, so initially it's moving to the right, and when we on the power supply, it also will pull to the right. It will also attract to the right. So that's why the charge, the first one, it is accelerate. Okay, the first one. Because initially you are moving to the right, and after that, when your power supply on, you also attract to the right. So it will accelerate, it will move faster. Okay. Okay, for number 2. Okay, number 2. Initially, the positive charge is moving to the left. Okay, initially without the power supply. So when we on the power supply, what happens is this positive charge, it will attract to the negative plate. Okay, so you want to move to the left, but it will attract to the right. So meaning that it will slow down your positive charge. So that's why it will experience deceleration. Okay, it will decelerate. Okay, so this is what it means. Okay, so we read, if the electric force on the positive charge is in the same directions of the motion, so it will accelerate. If the electric force on the positive charge is opposite direction, so it will decelerate. Okay, so next we go to the negative charge. Okay, negative charge. Here this is a negative charge. So initially the negative charge, the first one is moving to the left. Okay, meaning that initially before the power supply on is moving to the left. So when we on the power supply, what happens is it will attract, negative charge will attract to the positive plate. Okay, so initially you are going to the left, and then after that you attract to the left. So we don't need to do extra work. This charge will accelerate. Okay, it will accelerate because same direction, so it will accelerate to the left. Okay, so since the directions of V equals to the force, so it's the same direction, so the charge will accelerate. Okay, the charge will accelerate. This one is okay, so this one correction. The negative charge will accelerate. The negative charge. Okay, this one should be in the negative charge. Will accelerate along the straight line. Okay, so similar, this one also wrong, negative charge. Okay, case number 2. Okay, case number 2 is initially your negative charge is moving to the right. Okay, this is before the power supply on. So next, if we on the power supply, what happens is this negative charge will attract to the positive plate. So you want to go to the right initially, but when we power supply on, your charge is pulling, attract, the negative charge will attract to the positive plate to the left. So you want to go to the right, and it will attract you or pull you to the left, meaning that it's opposite direction. So since this is opposite direction, meaning that it will decelerate. Okay? Maksudnya kalau you nak pergi ke kanan, tetapi when we on the power supply, charge negatif itu dia akan ditarik, ya. Okay, ada satu daya tarikan yang tarik negative charge itu ke sebelah kiri. So satu ke kanan, satu ke kiri, of course you punya charge akan jadi lambat lah, kerana ada satu force yang tarik you ke sebelah opposite direction. Okay, so this is case number 3. Okay, this is case number 3. Okay, case number 4 is the charge in the dynamic equilibrium. Okay, so since we say it is a dynamic equilibrium bermaksud seimbang. Okay, it's seimbang. So dynamic equilibrium means the charge move with the constant velocity perpendicular to the directions of electric field, and the total force acting on the charge is 0. Okay, so actually this is a little bit similar with the charge number 1. Okay, so if the questions give you the mass of the particle, meaning that the question asks you to consider the weight. Okay, so if this is a negative charge, okay, initially it is a negative charge, and negative charge will pull upward, okay, to the positive plate, because negative will pull to the positive plate. Okay, but at the same time, if the questions give you the weight of the charge, so you need to consider the weight is acting downward. Okay, so therefore our force acting upward will equals to force acting downward. Okay, so this is EQ equals to mg. Okay, only particle with this constant speed can pass through without being deflected. So if because F equals to our weight, meaning that your particle is undeflected, maksudnya without being deflected. Dia tidak dipesong, tidak dipesong. Okay, so since your Fe equals to our weight, meaning that your charge, if let's say Fe equals to weight, meaning that If let's say this is 10 Newton, this one also 10 Newton. So your charge is not pulling upward and not pulling downward. Okay, so it will continue move with the horizontal line. Okay, it will move with a horizontal line, or we can say it is undeflected. Okay, tak dipesong ke atas, tak dipesong ke bawah. Okay, if let's say Fe equals to our weight. Okay, because just now case 2 is deflected because we don't consider the weight. So if the questions give you the weight of the particle, okay, so you must use this case number 4. Okay, case number 4. But important thing is if the questions give, okay, or mention about the mass of the charge. If they give you the mass or they give you the weight of the charge, okay, weight or mass, then you need to use case number 4. Okay, next one. Okay, finish our 4 cases. So we go to the derivations. Okay, consider a uniform electric field is produced by a pair of a flat metal plates. Okay, or we can say it is a parallel plate. Okay, parallel plate. So one at which is Earth and the other is at a potential of a positive V. Okay, so meaning that this is if V is higher than the negative plate. If let's say this is 100 volt, this one will be 0 volt. Of course, at here, maybe this is 99 volt. Okay, and maybe here is 98 volt. Okay, it's reducing. Okay, this one maybe is 97 volt and so on. Okay, so it's reducing until finally when you reach the negative plate, it will become 0 volt. Okay, it will become 0 volt. Okay, so this is the graph where the gradient of this graph, the gradient of this V versus R graph, okay, is equal to the gradient for V versus R or V versus D graph is actually equals to our electric field, or is equals to E lah. Okay, is equals to E. Okay, so the graph is a straight line with a negative constant gradient. Okay, with a negative constant gradient. So therefore, our E equals to change of V minus change of delta R. Okay, so 0 minus V over D minus 0. So our equation for electric field in the paraplate is equals to V over D. Okay, so this equation we can use only for parallel plate. Okay, E equals to KQ over R square. These equations only for point charge. Okay, if paraplate, we use E equals to V over D. Okay, we go to the example. Okay, so example, we have 13, 14, 15. Okay, so we go to 13 first. Okay, a particle of mass 5 milligram. Okay, 5 milligram. So if you look at these questions, they give you the mass of the particle. So remember, when they give you the mass, meaning that you must consider F equals to our weight. Okay, meaning that force acting upward is equals to weight acting downward. Okay, so this is the questions. And it carries of 2 microcoulomb is held at rest in the between of the 2 parallel plate metal. Okay, calculate the electric field strength between the 2 plates. Okay, as I mentioned just now, when the questions give you the plate, okay, okay, you must first you must know F net equals to 0. Okay, because it's at rest. So your F must equal to weight. F equals to EQ, and weight equals to mg. So finally, our E will equals to mg over Q. Okay, where m they give you 5 milli. So 5 times 10 to the power of 3, 9.81. Charge is 2 micro. Okay, 2 micro. Okay, so you will get, okay, press the calculator. So you will get 24.5 Newton per coulomb. Okay, so this is the answer. Okay, and there's a correction at this table. Okay, there's a correction on this table because this is a negative plate. Okay, so this is a negative plate. This is a positive plate. Positive plate. So positive plate meaning that the arrow here is wrong because the arrow, okay, the arrow is from plate positive to plate negative. So the arrow should draw upward. Okay, so please do correction because it's from positive plate to negative plate. Okay, the electric field, this electric field line is from positive going to negative plate. Okay, so please do correction. Okay, next we go to B. If the particle move upward with the constant velocity, what would happen to the value of E? Okay, explain. If the particle move upward, so what happened? If the particle move upward with a constant velocity, what would happen to the value of E? Okay, so E for a paraplate, for a parallel plate, we must use V over D. Okay, you cannot use KQ over R square because it's for paraplate. Okay, what happened is if the particle is moving upward, your electric field remains the same. Why? Because the net force is still equals to 0. Because the question say the particle move upward with constant velocity. So when we say V constant, meaning that your A equals to 0. When A equals to 0, your F net also still equals to 0. So there's nothing changes. Okay, that's why your electric field strength will remains the same. Okay, so you may pause the video if let's say you still calculating the value. Okay, next questions is example number 14. Okay, example number 14 is they give you a paraplate, negative plate upward and a positive plate at the bottom. Okay, so this S 2.25 is at SX. Okay, 0.618, this is actually is our D, is our SY. Okay, okay, so figure shows an electron. So this is an electron. So remember, later when you substitute the charge, you must put negative, negative. Okay, because it's an electron entering charged paraplate with the speed. So initially, okay, your UX is equals to 5.45 times 10 to the power of 6. Okay, and of course, because initially only UX, no UY. So your UY is equals to 0. Okay, the electric field produced by the paraplate are deflected, be deflected. The electron downward. Okay, why deflected the electron downward? Because this is an electron. So electron, it will pull, attract to the positive plate. So at the end, it will move in a parabolic path. Okay, at the distance of 0.618 cm. Okay, 0.618 cm. So this is our SY. Okay, and it is moving downward. So we put negative 0.618 times cm, we change to meter. Okay, why I put negative? Because it's acting downward. Okay, acting downward. Of course, your of course your XX is equal to 2. Wait. Okay, so your x-axis here, this is your x-axis, and your x-axis is equal to 2.25 times 10 to the power of negative 2 meter as well. Okay, so this is xy and x-axis. Okay, at the point where the electron exits, Okay, E is given 1.6 times 10 to the power negative 19, but because it's an electron, so you must put negative. Okay, you must put negative. And the mass for the electron is 9.11 times 10 to the power negative 31 kg. Okay, so first, what should you do is they ask you to find the electric field. Okay, they ask you to find the electric field. So electric field, F equals to MA, because it's accelerated, equals to EQ. So our E will equals to MA over Q. Okay, so N, because this is an electron, so it's 9.11 times 10 to the power of 31. A, we don't know. A, we need to find out. Q is a negative because it's a negative charge. So we must substitute negative 1.6 times 10 to the power negative 19. So we need to find acceleration first. So accelerations. So accelerations, AX of course is equals to 0 because your UX always equals to VX. Okay, it's constant. But we can find UY. Okay, so when you want to find UY, AY, you at least must have 3 informations. Okay, you must have 3 informations. AY. Okay, your AX is equals to 0. So AY, you must find AY first. But we need 3 informations, but we only have 2 information. So actually, it's not enough. Okay, so we can find T first by using X component informations. Okay, we know that XX equals to UXT. Okay, so we find out T first, where XX equals to 2.25 times 10 to the power negative 2. Okay, UX is 5.45 times 10 to the power of 6, and then T. So your time taken, okay, if you press calculator, time taken, you will get 4.13 times 10 to the power of negative 9 seconds. Okay, so if time for X component actually is equal to Y component as well, so your time is 4.13 times 10 to the power negative 9 seconds. Okay, so now you have U, you have S, you have T, you want to find A. Okay, so the next step is we will use S equals to, okay, we'll use SY equals to UT plus half AT squared. Okay, but everything Y component. Okay, so SY is equals to, just now SY is negative, negative, because it's your charge is moving downward. So it's negative 0.618 times 10 to the power negative 2 equals to UY equals to 0 plus half, G is 9.81. Sorry, not G, it's A. Not G, because it's accelerate. This is not free fall. Okay, so it's AY. Okay, this is not free fall. It's accelerate because it's attractive force. So this is AY. T is 4.13 times 10 to the power negative 9. Okay, so find out your AY. Okay, so press calculator, find out AY. So AY, you will get, okay, press calculator. Okay, press the calculator, 0. Okay, so you will get roughly 2.99 times 10 to the power of 6 meter per second square. Okay, you press the calculator and see. Okay, then after that, you substitute into the equation. Okay, 2.99 times 10 to the power of 6. So your final answer, okay, here we have negative. Okay, so here we have negative. So finally, our electric field strength is 4126 Newton per coulomb. Okay, Newton per coulomb. So this is the answer. Okay, B. the speed of the electron when it exit the paraplate. So when it come down, okay, you come down, the speed here is we need to find VR. But before we find VR, we must find Vx and also Vy first. Then only we can find the magnitude and also find the direction. Okay, so case like this, we need to use 5 steps. Okay, when you want to find the resultant, okay, when you want to find the resultant, you must use 5 steps. So step 1, you must find Ux. Step 2, you must find Uy. Okay, so Ux is equals to, sorry, Vx is equals to Ux, where your Ux is equals to 5.45 times 10 to the power of 6. Okay, and then your Vy is equals to U plus 80. Okay, so since U is equals to 0, Uy, so it's equals to 80. And your A is negative 2.99 times 10 to the power of 6. Time taken just now, we recalculate equals to 4.13 times 10 to the power of negative 9. Okay, so finally, you have your Vy, and your Vy is equals to negative 2.9. Correct or not? Wait, I calculate. Okay, wait. Just now, there's a mistake here. Okay, s equals to ut plus half at squared. Okay, here's square. Okay, sorry, teacher make a mistake. So please do correction. Okay, please do correction. Okay, so you recalculate. You recalculate your a. You will get just now a is okay. Your a is you should get negative 7.31 times 10 to the power of 13. Okay, so you substitute inside. Okay, so you substitute the value inside. Your answer, this one, A also wrong. Okay, so A also wrong. Okay, so you calculate first. Okay, you calculate the value A. Okay, you recalculate. Okay, so you recalculate and then you substitute A. So the answer that you get for velocity is 2.99 times 10 to the power of 6 meter per second. Okay, so you recalculate A by yourself. Okay, now step 1, find Vx. Step 2, you find Vy. Step 3, you must find the resultant. So you find Vx squared plus Vy squared. Okay, so you will get the magnitude 6.22 times 10 to the power of 6 meter per second. So this is step 3. Okay, step 4 is you need to find the direction. So by using tangent theta, Vy over Vx, so we modulus. Okay, so the angle that you get is 28.75. And the angle is because your x-axis is positive, your y-axis is negative, so positive, negative, so meaning that at the 4th quadrant. Okay, so this is example number 14. Okay, example number 14. So that's all for this subtopic 1.4. Okay, so example 15. Example 15. Okay, example 15 is your homework. Okay, this is your homework. Okay, so please send into our Google Classroom. Okay, so this is your homework. Okay, thank you, class. See you in the next video.